All right, so we're going to start out looking at 2.2, part 2. And we're going to do we're just going to start with a word problem. And this word problem is going to have to do with a company that has what we call fixed costs and variable costs. So a fixed cost might be like the rent they pay on the building to rent the factory. Doesn't matter what they do in the factory or how many they produce or whatever they're making in the factory. They just have to pay maybe $10,000 a month, and that's the rent for the building. Then, depending on how many items they produce, well, then they might use more materials. Like if they print T-shirts, they're going to use more T-shirts. They're going to use more ink. So the more they make, that's a variable cost. Depends on how many shirts they make. So this particular company has a fixed cost of $200,000. And a variable cost, okay, this company makes T-shirts, of $1.50 per shirt. So that's the cost for them to make the shirt, print it, whatever they got to do. Now, each shirt that they make is going to sell for $4. So kind of where we're going with this is, if they sell a certain amount of shirts, they will make back their fixed cost, and then they'll start making money. So we want to kind of figure out how many shirts does this company have to sell before they start making money. So maybe the $200,000, that was like all the equipment they had to buy to make the shirts. But once they buy the equipment, they have it. Now they can just use it. Okay, so we're going to do a graph of a couple different things. We're going to look at cost. We're going to look at, so that's how much money they have to spend. We're going to look at the profit, which is how much money they make. And we're going to kind of look at Roseg's graphs. We're going to hopefully find where they cross. And that point is something special. Okay, so we'll talk about that. All right, so the first thing we're going to look at is the total cost, which is money they spend, and the total revenue, which is money that they take in. Revenue isn't necessarily profit. Revenue is just the money that they take in from making the shirts. If we look at the difference, then we can find the profit. Yeah.
Is that point, that intersection where the revenue turns into profit?
So once it turns into profit, yeah, it's called a break-even point. Yeah. Yeah. Okay, so we need to pick a variable that represents the number of shirts we make. Let's just go with X. So X is number of shirts. Okay, so let's start with the formula for the cost. Can anyone give me a formula for the cost of making X shirts, including the fixed costs and the variable costs? Yeah.
150x plus 200,000.
Right. So it's $1.50 per shirt plus 200,000. Okay, so that's a formula for the cost. And now I want a formula for the revenue. Again, revenue is not necessarily profit. It's just the money that they get from selling shirts. What would that be?
How many shirts they need to sell?
Yeah, just raise your hand for me.
I know how many shirts they can make with $200,000. I checked that already. Yeah, 133,000.
So we're gonna figure out how much they have to sell to break even. That's eventually what we're gonna do.
X times 2.50. Let's say 200,000 minus X times 2.50, because $4 to sell a shirt, 150 to make it. 4 minus 1.5 would be 2.5. So you can just do 2.5 times the number of shirts and subtract that from the constant.
So if we're thinking about profit, then we have to get a little bit fancier with the formula. But revenue is just money you take in. Just the money you take in from selling shirts.
So that'd just be 4x.
Just 4x, yeah. So the revenue is just money you take in. Cost is money you put out. then the difference between revenue and cost, if it's a positive, then you've made money. If it's a negative, you've lost money. Okay, so now let's graph those and see what they look like. So I need my graphing calculator. And we're going to put those in. What's the y-intercept on the first one? 200,000. So we're going to have to set a y-max at least to 200,000. But our costs are going to go even higher than that for every shirt we make. So we probably, maybe we even want to go to like 300,000 for the y-max. Okay. Let's try that. What's the minimum number of shirts we could make? 0. The maximum number? Well, there is no maximum. The goal is to see where these cross. Let's see if that happens within making 20,000 shirts. If that's not enough, we'll have to set it bigger. Y min? Well, none of these numbers can be negative. You can't have negative revenue and you can't have negative cost. You could have negative profit, which is the difference. But cost and revenue are both positive numbers. It doesn't cost you negative $10 to do something. Okay, so 0 would be the smallest. And what did I say for y max?
300,000.
300,000. Okay, let's try it. Yeah, it's not going to be enough. So there's my costs. There's my revenue. You can see that the revenue is catching up, but it's not going to catch up within making 20,000 shirts. Let's bump it up to, let's try 120,000 shirts. Might have to set the y-max higher too now. Yeah. But now we can see the revenue is definitely going to catch up. I don't think we have to set the shirts any higher. We need the y-max higher. So let's try 400,000. Yeah, we'll see it now. Okay, so there's our cost, there's our revenue. And I would say that's a good complete graph. So you want to write down those values. Okay, x min, 0. X max, y min, and y max. It's not the only window, but that's a good one. And I think that's all they wanted us to do, find complete graphs. So any questions on getting that picture on the screen? Okay, now they're going to ask us to do something with it. Specifically, they're going to ask us to find what's called a break-even point. So the break-even point is when cost equals revenue. So I kind of just told you the answer. So graphically, it would be where your two lines do what?
Cross.
Yeah, it's where they intersect. So if you have cost and revenue, it's the intersection. And the break-even point is the point at which you start making money. You've recovered all your costs, and from that point forward, the more you sell, the more money you make. And now we're going to do that for that problem. Yeah?
I have it.
You have it?
Yeah.
All right. What did you get?
X is 80,000 and Y is 320,000.
Okay, so yep, X is 80,000 and Y is 320,000. That's the intersection. Let me get that graph on the screen. Does everybody have this part for a graph of cost and revenue? It's the intersection. Okay. All right, so we did it graphically first, which is fine. I'll scroll down and let's just put the answer down there for that first. So graphically, there we go. So it's 80,000. So what does that mean? Like the intersection point is 80,000, 320,000. Explain to me what those two numbers mean. Yeah?
80,000, if I remember correctly, is That's the number of shirts you need to. That's the number of shirts you need to sell. The
Okay.
X is the number of shirts you need to sell. Well, Y is the amount of money that needs to be paid.
So if you sold 80,000 shirts, how much would it cost you to make 80,000 shirts? Yeah,
Would be 320,000.
320,000. If you sold 80,000 shirts, what would your revenue be? Revenue.
Yeah, it's 320.
Your revenue would be 320,000. Your profit at that point would be the break-even point, would be 0. So if they ask you what is the break-even point, that's the coordinate. And now if you sell more than 80,000 shirts, you make money. So how do we do that algebraically? Well, it says it's the point at which cost and revenue are the same. So just set cost equal to revenue. The formula for cost, what was that again?
1.5x or 150x plus 200,000.
Plus 200,000. Revenue was 4x. So to solve it algebraically, you get 200,000 equals 2.5x. And how would you get x by itself? Divide by 2.5. And you could try it. Take 200,000 divided by 2.5. And you will get 80,000 shirts. So that's the number of shirts you need to sell to break even. Algebraically and graphically. Any questions on that? Again, that's called a break-even point. And you can do it either way. Just if the directions specifically say to do it algebraically, just make sure you show your work. If the directions say to do it graphically, there's not really a lot you need to show. Right, that's it for section 2.2. That was pretty cool. All right, so 2.3, that's what we're going to spend most of the time on. And I don't really think there's going to be anything new how to solve linear and quadratic equations. The only thing we are going to look at, which I don't know if you ever have or not, is where the quadratic formula comes from. So why is it negative b plus or minus? How do you get all that stuff? So we will look at that. Has anybody looked at where the quadratic formula comes from? Okay, so we'll take a look at that. So a lot of review stuff here. So remember, if you know this, you don't need to write it. Remember an equation. It's basically when you have two expressions and you put an equal sign between them. You can use a lot of different variables. X is pretty common. Y is also common when you start getting into graphing. In general, we can pick any letter that makes sense for our situation. So if you have an equation that uses x as the variable, then you could say you have an equation in x. So if you ever see directions that say write an equation in x, it just means to write an equation using x as the letter. And remember, expressions can be numeric or algebraic. So I think, do I give different examples? No, I don't. So this is an equation. It's a contradiction. This is an equation. That's an identity. This is also an equation. I think we did these three types at one point before. Contradiction, identity, and does anyone remember what this one was called? Begins with a C. Conditional. Conditional. Yep, that's a conditional equation. It could be true if x meets the right condition. So to solve an equation means to find the value of x that you could plug back into the problem that makes it true. Now, when we talk about solving, you're not obviously solving 3 equals 2 or 4 equals 4. We're talking about solving an equation that has a letter. Okay, so we're talking about conditional equations. Okay. Yeah, just sign up for me. I actually do give you some examples. So an identity is an equation that is true for all values of the variable. Now, 4 equals 4 is an identity. You probably wouldn't be given that as a problem if it was an identity. You'd be given something more like this, where if you look at it, maybe in the first second, it's not clear that it's an identity. But if you do distributive property on the right-hand side, you get 3x plus 3 minus 1. So you get 3x plus 2 on the right, and you have 3x plus 2 on the left. If you subtract 3x from both sides, you end up with 2 equals 2, which is an identity. So that means no matter what value you pick for x, this equation is always going to be true, because it's the same thing on both sides. You can't find a value for x that would make that false. It's impossible. So that's an identity. And then a conditional equation, well, that's an equation that's true sometimes. Depends if you pick the right number for x. Okay, so something like 2x equals 10, as long as x equals 5, that is true. If x is anything except 5, it's false. And the only one I didn't put up here was a contradiction. And that's usually when you end up with something like 2x plus 6 equals 2x plus 9. Well, if you just look at that from like a common sense point of view, you can't double a number and add 6, and then double a number and add 9 and get the same result. If you double a number and add 6, and you want to get the same result, you need to double the number and add 6. You can't add something different and ever get the same answer. So if you subtract 2x from both sides, you get 6 equals 9. That's not true. So that's a contradiction. Any questions on those, what it means to solve an equation? Or the 3 types: identity, contradiction, conditional. So this section focuses mostly on linear and quadratic. Pretty much we can solve all those without a graphing calculator. If we get into something higher than quadratic, you might need a calculator. Depends. Okay, so how do you check if a number is a solution? Well, you take your answer, plug it back in, and you see if you get a true statement. So just looking at kind of a simple one. 2x equals 50. All right, what do we think x would be there? Yeah?
X would be 25.
Yeah. So x would be 25. So to check it, take 25, fill it back in for x, and see if the left side and the right side come out the same. In that case, 2 times 25 is 50, which equals 50, so it works. All right, so here's a cubic. You may or may not know how to solve something like that without a calculator. By the end of this year, depending on what kind of answer this problem has, you might be able to figure it out without a calculator. As long as there is a rational answer, meaning an answer that you can write as a fraction, we can get it without a calculator. If the answer can't be written as a fraction, then yeah, you're going to be kind of stuck. There is a formula called the cubic formula, which is like a quadratic, but we never learned that. Yeah.
I was just gonna ask, isn't it like a really long?
Yeah, the cubic one, it's not too bad. It's significantly longer than the quadratic. And then there's one for 4th degree, and that one's very long.
Wouldn't that just be completing the square for the cubic?
Well, I guess if you, well, it's not completing the square because it's a
Complete
cubic.
the cube. So basically that figure we have multiple parentheses that when you multiply them all together make that equation.
Yeah, we'd ideally want to factor this.
Yes.
We'd have to figure out how to factor it, which could involve a little bit of long division, synthetic division, and then, yeah. But we don't have to actually factor it. They just want us to verify that -2 is a solution. So it's basically just, let's check your answer. Okay, so how would I check that -2 is a solution? what do I do? Yeah,
Plugging it in.
yeah, just plug it in. Okay, remember, if you do want to do that on the calculator, you have to put the -2 in parentheses. Otherwise, it's going to cube the 2. Like if you do this, that cubes the 2 and gives you 8, and then it throws a negative in front. So if you type that in on the calculator, you get -8. If you put parentheses around it, it does -2 times -2 times -2.
It still gives you -8.
Which would still give you -8. So yes, if it's an odd exponent, it technically doesn't matter. But when you start doing even exponents, like if you did -2 to the 4th, I mean, we know that a negative to an even power should be a positive number. But if you type that in without parentheses, the calculator would give you -16. Okay. All right, so we're going to put +6. I usually just put a question mark because we don't know if it's equal. That's what we're checking. Okay, so -2 cubed, we just said is -8. What happens with minus -2? Plus.
Plus positive.
Yep, so +2. And then what's -8 plus 2? -6 plus 6, 0. So when you get 0 equals 0, you've checked your answer, and it works. Okay, I know I'm going kind of quick through this, but hopefully nothing new here. Any questions on that? All right, so what is a linear equation? Well, the definition of a linear equation is basically anything that can be written in the form ax plus b equals 0. Even if it's not in that form, but you could rearrange it so it's in that form. It's like rearranging to y equals mx plus b. So anything that can be rearranged to look like that is linear. Now this is saying that, well actually you tell me, what is that saying there?
A and B are all real numbers, where A is not equal to 0.
Yeah. So this symbol, if you want to be really technical, means element of. So A and B are elements of the real number system, or they are numbers from that system. But A can't be 0 because if A is 0, 0 times x is 0. Now you have B equals 0. That's more of like a constant equation when you get rid of the x. Okay, so linear equation has to be able to be written like that, and A can't be the number 0. So that's a linear equation. It doesn't look like ax plus b equals 0, but if you do some distributing, combining, and moving, you could make it look like that. Right, so let's solve it. Lily, what would be my first step to solve this equation?
Distribute.
Yep, and can you tell me what you get when you do the distributive property everywhere you need to?
4x minus x plus 3x plus 3 equals 5x plus 2.
Perfect. So there's our first step. Do out all the distributive property. What would we do next?
Combine like terms.
Yeah. Well, can you tell me what you get when you combine all your like terms on the left
have
side?
a 7x, and I'm pretty sure it would be a 3. -3.
-3. All right. So now we've combined all our like terms. How about my next step?
Variables minus 5x both sides.
Okay, so let's do that. And what else can I do at the same time?
You would also add 3 to both sides.
So 5x is gone, 3 is gone. So now we have 2x
Equals 5.
equals 5,
X equals 5x.
and x equals 5x. Okay, so not the simplest linear equation, but at this point, you should feel very comfortable with solving something like that. Okay. Any questions on that? Now we're not going to check that. We could, but we're not going to. Okay, so absolute value equations. Absolute value equations basically are like solving two linear equations at the same time. So what you might have is something like this. Generally, absolute value equations can have two answers because there's two numbers that 3x minus 4 could come out to. And it would still give me an absolute value of 12. What's one number that 3x minus 4 could equal? Not the x, just the 3x minus 4. If that comes out to 12, we're gonna be all set. Or if 3x minus 4 comes out to negative 12. And those are the two equations right there. 3x minus 4 equals 12. 3x minus 4 equals negative 12. So the first equation, 3x minus 4 equals 12, is exactly the same as the original problem. You just take out the bars. Now the second equation, you just change the sign of the number on the other side. Or another word for that is negate. That means change the sign of. So the second equation is the same as the original. You take out the bars, but you also change the sign of the number on the other side. Now, in most cases, you're going to be able to jump right to this step by splitting it into two equations. And in that one, you can jump right to that step. But if the absolute value expression is not by itself, you have to fix that. So let's say you had something like this. Now, we don't have the absolute value isolated. We have a plus 4 in front of it. So anyone have a guess what you would do first to get the absolute value isolated? Next? Yeah. Yeah, how would you do that? Yep, you'd subtract the 4 from both sides, and then it would be isolated. Okay. Same idea if you get something like this. Three times, and again, it'll look a bit clearer on the computer or in the book, but that's an absolute value. 3 times the absolute value of 2x minus 12 equals 30. Okay, we got to isolate the absolute value there first as well. How would you get 2x minus 12 by itself? Yep.
Divide by 3.
You'd have to divide by 3, and then you'd have absolute value of 2x minus 12 equals 10. Then you can split it. But you have to do that first. So let's look at this one. Absolute value of 2x plus 3 equals 5. Is that one ready to split, or do I need to fix it first? It's ready to split. Yep. So let's split it up. What's going to be my first equation that I write down when I get rid of the bars? Yeah. 2x plus 3 equals 5. And my second equation. Yeah, Joe?
2x plus 3 equals negative 5.
Yep, 2x plus 3 equals negative 5. So that's why I said absolute value really means you're solving two linear equations. So we're going to get x equals 1 is your first answer. And then here you're going to get x equals negative 4. Double check me, but that's it. Any questions on the two answers? They're both answers, so we do need to write both. Now, what if you had something like this? Yeah?
That's not possible for an equation.
Why not? It's ready to split, right? Because the absolute value is by itself, so why don't I just split it up?
Yeah, but you can't have the absolute value be equal to a negative because absolute value is meant to always equal positive. There's no change.
Right. So in this case, you could split it up into 2x plus 5 equals negative 17 and 2x plus 5 equals positive 17. But you're never going to get an answer that works because the absolute value is never equal to a negative. So that's a no solution. That's a no solution. Now, what if I had this? Would you look at it and say, okay, absolute value equal to a negative, no solution?
No,
Why not? I thought if it was equal to a negative, it was a no solution.
we still have something else we gotta add to the other side, in which case it would be equal to 3.
Right. This time, the absolute value is not isolated. So the first thing you do is add 20 to both sides, and then that gets rid of that negative with the 17.
But if it was still a negative number after doing it, still it would be no solution.
Right. If the absolute value is equal to a negative number and it's isolated, then there's no solution. Yep. Any questions on that one? Okay, so one more thing we're going to look at with linear equations, and that's solving a mixture problem. So the idea of a mixture problem is it's like a system. Okay, you're going to set up two equations. And generally what they're going to do is tell you you have two different solutions, like maybe a solution that's 15% strength and another one that's 20% strength. And I want you to mix the two together to maybe create something that's in between, okay, like 16%. And I'm going to say, okay, I not only want you to get 16%, I want you to make 30 gallons of it. So you're going to have a certain strength that has to be, and in a certain amount. So the idea is you need two equations. Generally, I use like x and y. X represents like the amount of solution I use from the first container. Y is the amount from the second. And the simple equation is just x plus y has to equal the total amount of solution they want me to make. So that's one. Yeah?
Do you end up setting it? Do you have any idea of the way Mr. Chris would set it up for us?
Oh, yeah, that's what Sandy does as well.
Yeah.
The box.
But there's like it's like a grid almost.
Oh, yeah.
Matrices?
No.
Just to organize the information.
Yeah, it helps you to remember how to multiply. Like,
It made it
or
add
add
it.
it's easier certain numbers.
All right. Well, maybe when we do one, you can show me like the box thing. So this is your first equation, and it just involves amounts. It doesn't involve anything with the percentages. The second equation involves the percentages, and it has three things in it: concentration times amount, concentration times amount, concentration times amount. It's all concentration times amount. The concentration is going to be given to you in the problem, usually as a percentage, like 12%. Anytime that we are given a percent, we always have to write it as a decimal. Okay. So like 12% would be what as a decimal? 0.12. Yep. So this is your first concentration times how much of that liquid you use, usually X. This is your second concentration times how much of that liquid you use, usually Y. And then this is your final concentration, which is given in the problem. And this is the total amount of liquid that they want you to make. And that's given to you as well. So the things I'm highlighting, these are given. Given, 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 given. Given. The only thing you have to do is pick a variable for amount 1, I use X, and variable for amount 2, I usually use Y. But the other 5 things are all given. Okay, let's try an example. First, I'll make sure people have those two equations. Yeah. So here's what the problem looks like. We have two solutions. a 10%, and a 25%. Now, you can mix them together to make anything in between 10 and 25. You can't really go lower than 25. You can't, or lower than 10. And you can't go higher than 25. To go higher than 25, you'd have to reconcentrate the solution, which you can do. But that's a little more complicated sometimes. Like, yeah, we're not going to really get into that. So we got those two solutions, and I want to mix them together so that I end up with exactly 15 liters of liquid, and I want the strength to be 12%. So just based on the strength of the final mixture, which solution do you think I'm probably going to use more of, A or B? Yeah.
You're going to use more of A because you want it closer to 10, but you want
So it's going to be closer to A. I said X and Y. I guess this time I'm going to use A, B. That's fine.
Okay, I remember it. I know how to write it out. The box method.
Okay, give me 1 second, and then we'll take a look at it. So let's just write down those letters because that's what we're going to use. So off to the side, I'm just going to put let A. Actually, you know what? I can write it even simpler. Let's just make a column right here. Let's call this amount. So the amount of solution A that I'm going to use, I'll let be capital A. And the amount of solution B, I'll let be capital B. So A and B are amounts. Okay, so let's set up the two equations the way I showed you, and then we can take a look and see if there's
You basically
different
want to say the way the box method way with that.
So the first equation represents the total amount. The amount of the first solution plus the second solution, and then the total you want. Well, what's the total that we want? Yep. Okay, we want 15 liters, and we know we're going to mix two solutions together to do it. How much of the first solution am I going to use? A. That's the amount of the first solution. What's the amount of the second solution? Yep. B. Now, if that's all you knew, then A and B could really be a lot of things. You could do 1 liter and 14. You could do, 5 and 10, 10 and 5. But the thing that narrows it down is we want it to come out to a certain concentration. So the second equation is all concentration times amount plus concentration times amount. And then, just to be clear here, this is the final concentration times the final amount, or the total. Okay. So let's start with the concentration of the first one times how much? What's the concentration of the first solution?
0.1.
0.1. And how much of that solution are we going to use? A. And then the concentration of the second solution?
0.25 B.
0.25 B. And now, final concentration
1.8.
is how much?
1.8. 0.12 times 15.
So the final concentration is
12% of 15.
12%. And what's the final amount?
15.
15. Okay. I do want to see the box thing, but maybe I'll have to see that at the end. I do want to. You have it written down.
I have it already set up and I already have it set up.
Now, with 0.12 times 15, you might as well just simplify that because that's just multiplication. That comes out to 1.8. Okay, so when we rewrite that, we'll just write 1.8. The other thing we need to do is we have two variables to solve for, and we have two equations. So there's a lot of methods you can use. You can use elimination. You can use a matrix. You can use substitution. What do you think the easiest method to use here would be? In fact, it's almost set up to use this method.
Set A equals to something or B equals to something.
Yeah, I would use substitution because we almost have A or B by itself. Well, I should ask this. A or B is almost by itself in which equation? 1 or 2?
Number one.
Yeah. I think the first equation, it's easier to isolate a variable in. What variable do we want to isolate?
I would say variable A you'd want to isolate because that's the one that's going to have to move through.
Okay, yeah, it doesn't matter. You could do either one. It's going to be pretty much the same steps. What do you get in that top equation if you isolate A?
15 minus B.
15 minus B. Now, what do I do with that 15 minus B? In fact, just to make this a little clearer, I'm just going to go like this.
You can plug it in for the second one.
Yeah, you're just going to take that and you're going to plug it in for A in the second one. And then once you do that, you're only going to have B in the second equation, and that's going to be the variable you find first. All right, so we've got 0.1 times A, which is 15 minus B, plus 0.25B equals 1.8. Okay, we've got to distribute the 0.1. What's 0.1 times 15? Yep. 1.5 minus 0.1b plus 0.25b. Okay, now let's combine what we can and move something to the other side. What can I combine in here? Yep.
0.1 and the 0.5.
So I got the negative 0.1 and the 0.25, which gives me
0.15b.
0.15b. And what would that be equal to?
0.3.
0.3. And then 0.15 goes into 0.3 how many times?
2 times.
2 times. So for solution B, we need 2 liters of it. And we know that we're working with a total of 15. So how much do we need for A?
13.
13. So if you mix 2 liters of solution B, 13 liters of solution A, you'll get exactly 15 at 12%. Okay, and after, hopefully we'll have a couple minutes, we can look at that other way to do it.
Quick question. Where did you get 0.1 and 0.5?
The negative 0.1 comes from distributing negative 0.1 times 15.
Right, where did you get the 0.1 in the first place?
0.1, that's the concentration of solution A, 10%. And the concentration of solution B, 25%. Other questions on that? Okay, so that's all linear. Okay, applications of solving linear equations. Now we're going to look at a quadratic. Okay, which we've done before, so I'm not as interested in do you know how to solve a quadratic. I'm more interested in figuring out where does the quadratic formula come from. Okay, we'll also talk a little bit about factoring. I know some people aren't as good with factoring. It's kind of one of those things you get better when you practice it. So this is similar to what I said about linear equations. They're of the form ax squared plus bx plus c equals 0, where the a, b, and c can be any number you want except a can't be 0. Because if a is 0, then you would wipe out the squared term. And what would you be left with if you do that? Yeah, you'd be left with something linear. Okay, so we're specifically talking about quadratics. So one way to solve them, I think, is a pretty quick way. If it factors, you're going to get nice answers, and it's a lot faster than trying to use quadratic formula. So let's see if we can factor this. So 2x squared plus 5x minus 3 equals 0. Okay, what's the very first thing you usually write down when you're trying to factor a quadratic? Yep.
Well, you notice the negatives and the positives of it, because that would tell you what would, you'd figure out whether it was a x minus something and a x plus something or whatnot.
So yeah, the signs in there are going to be important. Even before we get to looking at those, what's something you write down before you even really look at what the specific numbers are? Yep.
The two parentheses of the x plus or x minus.
So yeah, the two parentheses. Right? So that's usually the first thing I always do. So now you got it set up. And now you want to fill in these two spots. Well, there isn't really a choice here because 2 is prime. So what has to go in the first spot and the second spot?
2.
A 2?
No.
2x. Yeah, and
1x.
1x. Now, if this wasn't a prime number, like let's say that was a 24, well, now you've got all kinds of combinations that multiply to give you 24. But 2 is prime, so these are guaranteed to be right. Now, I have a positive 5 and a negative 3. What does that mean about my signs inside the parentheses? Both positive, both negative, one of each. Yep.
I'm sorry, I wasn't going to do it by the signs, but like it means like whichever you multiply it out, whichever number is going to be positive needs to be the bigger one. Like, does that make sense? Like 2x times whatever on the outside needs to be positive.
So are you saying we do need one of each? They're not going to both be positive or both be negative?
Only one of each.
It's going to be one of each, yeah. And we kind of want to think about this middle number's sign is positive. And since it's positive, we want the bigger calculation to be positive. Otherwise, it's going to come out negative. So I would probably try minus plus. If it doesn't work, we'll fix it. And 3 is prime as well. So there's only 2 numbers we can multiply to get 3. And that would be?
1 and 3.
1 and 3. So we could try it different ways.
That's the only one that would work.
I would suggest trying it like that. And that does work, because that's going to give you 6x minus 1x is 5x. Now, once you factor it, that's the hard part. What do you do with each factor? Yep.
Solve it out. Like,
How?
Set them both.
set them. It's already set equal to 0. So
Well, the entire thing is equal to 0, but now you have to,
set each factor equal to 0.
yes, set each factor equal to 0.
And then
And we're going to get x equals 1/2. And the other answer?
negative 3.
You get a 3. So pretty straightforward, pretty quick, because it factors. Now, if it doesn't factor, what could we do? We could use the quadratic formula. Okay, so let's take a look at the quadratic formula. So the quadratic formula would be used to solve an equation like this. ax squared plus bx plus c equals 0. Or at least you could get it equal to 0 if you put everything on one side. Now, we have another way we can solve quadratics without using the quadratic formula. And that's what I want to do on this. Well, I don't have any numbers that I can really graph, so I can't type it in. But what's the other method you can use to solve quadratics?
Discriminant, like the discriminant.
Well, we're going to kind of invent the discriminant when we do this. It's going to all of a sudden appear in the problem, b squared minus 4ac.
You're asking for what the quadratic formula is?
No, we don't know that yet. If you're looking for another way to solve a quadratic without that formula, if factoring doesn't work.
Complete the square.
Complete the square, yes. So what I want to do is I want to complete the square on this problem, right? So that requires us to know really well how to do it because we're not going to do it with numbers. We're going to do it with letters. So the first step to completing the square is to do what with the constant? Yep.
Bring it to the other side.
Put it on the other side. So ax squared plus bx equals negative c. Okay, so that's your first step. Now the second step is you need to make sure when you are completing the square that there is a certain number in front of x squared. Does anybody remember?
The constant?
Well, the constant we put on the other side. But what is the number that has to be in front of x squared when you complete the square? Like if there was a 5 in front of x squared, you're not going to be able to complete the square. It has to be a certain number.
Even?
It has to be 1.
No, it's not going to be even.
Does it have to be 1?
It has to be a 1. So anytime you want to complete the square, you need to do it so the x squared term is a 1. What could you do on the left-hand side to make sure that x squared is a 1 in front of it?
Divide by 8.
Right, or yeah, you could divide by a or basically like factor out an a, and we got to do it all the way across. Remember, whatever you do to one side, you got to do it to the other side. So yeah, you could essentially divide everything by a. I'm not going to rewrite the whole problem just for that step, but now you have that. X squared plus b over ax equals negative c over a. Okay. Any question on that step? Now we need to complete the square. So we would have x squared plus b over ax plus some number that we would add to both sides. And then you also are going to have to do it on this side. Does anybody remember? It has something to do with this. What do you do to this to get what goes in the box? You have to do two things to it. Yeah?
First you divide it by 2.
Okay, divide it by 2. So there's dividing it by 2.
And then you square it.
And then you square it. So that's what you need to add to both sides to complete the square. It's half of the thing in front of x squared. It's just not a number, so I can't make it look nice. Half of it is b over 2a, and then square it. b over 2a squared, and b over 2a squared. I'll just put parentheses, so. Now, if we did that correctly, the left-hand side should factor very nicely. It should factor into two things that are identical. Well, let's just get the signs first. It's a plus and a plus. So it's going to be a plus and a plus. Now I need something here and something here, so when I multiply them together, I get b over 2a squared. And they have to be the same thing. Yeah?
Wouldn't it be b over 2a?
Mm-hmm. What you put there when you factor it is always half the middle number.
I'm pretty sure you also have to have that in parentheses. That all needs to be solved before you can.
Yes, you have to keep it in parentheses, just like I have it. All right, now let's start looking at the right-hand side. We've got negative c over a. What do you get if you square b over 2a? You have to square the top and square the bottom.
You get b 2
b
You get b squared.
squared, yep,
And 4a squared.
over 4a squared.
So that like
So far, so good. Now, this side, since we factored into two things that are the same, let's stop writing it twice. Let's just do it like this. X plus b over 2a squared equals, and now I'd like to put those fractions together on the other side. But if I want to put them together, what do they need to have?
Same denominator.
They need to have the same denominator. This denominator already includes some of that denominator. So that's good. What could I multiply this by to make it the same as that one?
1/4 squared. Oh no.
You'd have to multiply it by 4a over 4a.
Mhm.
Because you can't just do it by 1 over 4a. It needs to be 4a over 4a.
And hopefully you're starting to kind of see something here. B squared minus 4ac. Okay, we're starting to maybe see the quadratic formula a little bit.
I'm confused with what you were doing.
So this is proving where the quadratic formula comes from.
Oh, this is where you just put more.
So we're completing the square. So on the right-hand side now, the denominator is 4a squared. And the numerator, I could write negative 4ac plus b squared, but I'm going to do b squared minus 4ac. Okay, I'm going to do it that way. And the goal is to get this x alone. And once we get x alone, you should have the quadratic formula on the other side. If you don't, then we did it wrong.
Isn't the quadratic formula negative b plus or minus the square root of b squared minus 4ac divided by 2a?
Yes, that's my goal. So what would we do next on the left-hand side to start to get x by itself?
Square root it.
Yep, you would square root it. Take the square root of what's on the left, and you get that. Take the square root of what's on the right, and you get, well, when you square root a fraction, you do the top and the bottom separate. The square root of b squared minus 4ac. And what's the square root of 4a squared?
It would just be 2a.
2a, yep.
Because we already squared it earlier.
Now, we don't really have that much more to get x by itself. What would be my last step to get the x by itself on the left side? Yeah.
Subtract b over 2a.
Yeah, and the nice thing about subtracting it is it already has the same denominator of what's on the other side, so we're going to be able to just write one big denominator all over 2a. So we get x equals, when you subtract this b, it's going to turn into a...
plus minus.
Numerator.
Oh, well, you're right. Yes, when I take the square root, I should put the plus minus there. That is important. But when you subtract the b, it turns into a...
Numerator.
What kind of b, though?
Negative.
A negative b. So it's going to be negative b plus or minus the square root of b squared minus 4ac. And now, instead of writing this over 2a and that over 2a separate, it's all over 2a because that's your common denominator. So every time that you use the quadratic formula, you are really completing the square. It's just the quadratic formula hides all the completing the square stuff by doing that stuff. But that's all the quadratic formula is. It's completing the square. Yep.
So for completing the square, you need to figure out what symbols to use, and you need to figure out what to multiply by what to get the entire equation. So in some cases, would it just be easier, even if it would factor completely, to just do the quadratic formula so you don't need to, if you can't like remember how it works, to just use that to figure it out? Like just plug the equation in and then it gives you the two parentheses and you can set both of them equal 0?
So you can always use quadratic formula instead of factoring, yes. It might be a little bit longer, but it will always work. Yeah. So any question on the formula? Again, my interest isn't in do you know how to use it. I hope you know how to use it. It was more, where did it come from? Like where is it just random or does it actually come from something? It comes from something. So we don't prove every formula, but if we can prove something and it doesn't take like 50, 55 minutes to do it, then we'll usually look at where it comes from. All right, so there is your quadratic formula. The part under the root is called the discriminant. I think we've already mentioned that this year. Remember, to use that formula, you need to make sure that it's equal to 0. That means you put everything on one side and 0 on the other. Doesn't matter what side you put everything on. Won't make a difference when you're solving for the roots. All right, so is there any question on how you would use quadratic formula on that one? Make sure we know what A, B, and C would be. What's A in this case?
2.
2. Which one? The first one. And B?
2.
2.
Second one.
And C?
-1.
-1. So you fill in the A, the B, and the C in those spots, and then you do it up. Okay, so if this was like algebra 1 or algebra 2, we take time, we go through the whole formula, but we've practiced, I think, a few with quadratic formula already this year. Okay, any question on that? Okay, so let's look at all right, let's just set this up. I'm not going to go through and solve it because I really want to do the last question, which is this one. If you wanted to solve this with quadratic formula, what do you need to do first? Yeah.
Subtract 1 from both sides.
Yeah, you could subtract 1 from both sides. I would also put it in this order. Now it's ready to solve. And if you want to use quadratic formula, what's A?
-1.
-1. B?
3.
3.
-1.
And -1. Yep, so you've got to get everything on one side to make sure you get the signs of your negatives right. Yeah.
Would you technically, would it be easier if A was positive?
If I was going to factor it, yes. Anytime I want to factor, I want x squared positive. But if I'm going to use quadratic formula, it doesn't really matter if A is positive or
Yeah,
negative.
if you're factoring, I would add x squared and
Yes.
subtract 3x.
Yes, I would. Yeah. But I have a feeling it's probably going to work out to be a quadratic formula since it's following that part of the lesson we just did. Okay, so last question. So this one says that we have squares that are being cut out of the corners of a rectangular shape, and we're basically going to fold the sides up on those dotted lines to make like a little tray with 4 sides. The original length and width of the piece of cardboard that we're making this tray from, I'm just calling it L and W. The squares that we cut out of the corners are 5 by 5, each corner, exactly the same amount. So then the cardboard is folded along the dotted lines to make a box without a top on it, just a tray. It says the length is twice the width. Okay, so that might be something important we need to know. And the volume that the tray can hold is 2,040 cubic inches. So the directions, what do they want us to find? Find the dimensions of the cardboard that you folded to make this shape. Now, when they say the length is twice the width, they are talking about, where did I write that? Oh, right here. They're talking about the tray that you make. The length of it will be twice the width of it. I would have worded that a little clearer, because that might not be clear what that means. Doesn't mean the original sheet of cardboard. It means the box that you make. This is all about the box that you make, like that. Okay, well, let's start with the volume of it's basically a rectangular prism. What's the formula for the volume of a rectangular prism? You would need to know that. Yeah?
Length times width times height.
Yeah, so the volume is length, width, height. Now, we're finding the volume of the box we're making, not the volume of the piece of cardboard. The piece of cardboard's flat. So, what would be the length of my box after I fold the sides up? Yeah?
The length of the box after it has its sides folded up would be length minus 10 because it's 2 5s.
Yeah.
On both sides.
It would be the length, it's that red line. It's the length minus the 5 you cut off of each corner. So it's length minus 10. That's the length. What about the width? Oops. What's going to be the width of the box? Yeah.
Would it be 2L minus 5?
Don't worry about the length being twice the width yet. For now, you can go ahead and just use W.
Okay. So W minus 5.
Minus. You're cutting something from each side.
Oh, minus 10.
Yeah. So W minus 10. And we're going to get back to what you said about the length being twice the width. And lastly, what's the height? Think about when you fold this side up. Yeah? 5. Okay, now we've got two different variables there which we don't want. But we have a sentence here that says length is 2W. So the length is twice the width. So we can make that substitution for L. So 2W minus 10 times W minus 10 times 5. And the volume, we already know. What is the volume?
2040.
2040. So now we just need to solve it. Now, if we're a little clever when we solve it, what could you factor out of this 2W minus 10?
2.
A 2. So you could have a 2 times 5 times W minus, oops. What would you have here if you factor a 2 out?
W minus 5.
W minus 5 and W minus 10. So I just copy down the W minus 10, copy down the 5, and then I factored the 2 out. But what's 2 times 5? 10, and then divide each side by 10.
204.
So now all we have is 204 equals, and now FOIL this out. W times W,
2W.
W
I'm
squared.
sorry, that was great.
W squared, minus 10W minus 5W.
15W.
Minus 15W plus
50.
50. So now we've turned this into a quadratic that we could set equal to 0. So W squared minus
50W.
15W,
Minus
I'm looking up what that is, 154. So minus 154.
equals 0.
And that does factor. You could use quadratic formula if you didn't see it. But it factors into W minus 22 and W plus 7. I probably wouldn't have noticed that. I would have just had to use quadratic formula, which is fine. So what is the two answers we get for W? W equals 22 inches, or W equals -7, but can width be negative? No. So we know the width is 22. So the length is 44.
I don't understand you got like a 2 and a 5.
Right here?
Yeah.
So I factored a 2 out of this and made it 2W minus 5.
Oh, okay. So where did you just moved the 5 over?
I just moved the 5 over so I could do 2 times 5 next to each other. You don't have to factor the 2 out, it just makes the numbers smaller.
Well, you do have
Okay, so that's the homework for tonight. And then tomorrow we will go over that first thing.